All right. Are we ready? Okay. Well, welcome to the last talk before the last talk. So today I just want to talk a little bit about aviation security. In particular, wanted to talk about how some of the different attacks that people have talked about as it comes to aircraft affect, the big planes, airliners, etc., differently from how they might affect little airplanes, little Cessnas and such. So I'm Dr. Phil Polstra from Bloomsburg University of Pennsylvania. Anyone else from Bloomsburg? All right. So, why this talk? In the last few years, there's been a lot of bold claims people have made about, I can hack, I'm going to hack your 777 with my smartphone or maybe my Arduino or something, something crazy. So, of course, all those bold claims get lots of press. And that's one reason. Another reason, if you look at general aviation aircraft, your little Cessnas and Pipers and such, things are very different from the world of airliners. And a lot of people don't really talk about, the differences between these two sets of aircraft. So some of you might know me. You might know me as kind of the hardware hacking guy, maybe author, forensics guy. Also, a little bit of an aviator. I have 17 aviation ratings. All of them are current. I'm a commercial pilot, flight instructor, airplane mechanic. I have an inspection authorization for aircraft. I'm an avionics tech. I'm a licensed skydiver, skydiving coach. I have a few thousand hours of flight time. I've built aircraft before, and I've actually worked on the development of some of the avionics that are sort of pertinent to the airliner discussions as well. So what are we going to talk about today? I'm going to talk a little bit about some of the common aircraft systems and how do they work. You might have heard people talk about ADS-B. They don't talk about it so much, but something that's also relevant is called ADS-A. You might hear people talk about things like ACARs and transponders and collision avoidance and, of course, GPS. You probably know about GPS because you got it on your phone now. Autopilots and things like that. How is all this stuff connected together? All right, so what are some commonly discussed attacks out there? Of course, the one that's fit for your average movie is, I'm going to hack in through the, in-flight entertainment system, and I'm going to completely take over this aircraft and things like that. Other people have talked about things like hacking ADS-B, sending out false signals in that system, or maybe even hacking engine systems and ACARs, right? So we're going to talk a little bit about some of these. Also, I recently discovered an attack myself last month, and I've dubbed this the spear smashing attack. So last month, I actually went to a conference in Iowa, and I got to the baggage claim, and this was my bag. I'm like, wow. But I feel like I was targeted by the airlines, and they just smashed the living crap out of my bag. And it was lots of fun dealing with that. Okay, so I said I want to talk a little bit about different kinds of aircraft. So here is a old general aviation aircraft. This, I want to say, is like a 1956 era Cessna here. Now, how do you think you could hack this airplane? Good luck, all right? I'm in a flying club, and we have a couple of airplanes, and our trainer airplane is actually a 1960 Cessna. It's very similar to this guy. And it's all analog electronics. There's no digital electronics, there's no GPS, there's no autopilot. All the radios are kind of like the radios in this picture. They're mechanically tuned. So the ability to hack that airplane is significantly reduced. You might see something like this. Can anyone identify this aircraft? Let's see. This is a Cirrus SR-22. Yeah, so you just didn't want to speak up, but you knew what it was. So this is a Cirrus aircraft. I just picked this one. There are other aircraft have very similar avionics systems, what we call glass cockpit airplane. This is a G1000 system from Garmin. Right? Really nice stuff. What do you think? Is the attack surface a little bit larger on this aircraft? Yeah. There's a little bit more electronics, a little bit more software going on here. Right? And what about this? Anyone identify this cockpit? You didn't know this was going to be cockpit trivia.
It looks like a miniature version of an airplane, or
You're closer. This is an Embraer 145 regional jet. Okay. But some of the regional jets, I mean, this is not as true as it used to be, but sometimes you look, like say 10 years ago, at a regional jet cockpit, and it looked nicer than the big jet cockpit, right? Because they were still sort of transitioning from that analog phase into the glass phase. All right. So, just a couple of things. You can't override pilots. They're kind of the last line of defense. You can social engineer them, but that's another story. Also, even the glass cockpit aircraft, they do have unhackable mechanical backup instruments. Now, I was talking to some folks earlier this week here, and we were talking about different kinds of airplanes. And one of the things we were talking about with the Cirrus is the Cirrus pilots get a bad rap, and it's probably justified, honestly. But there's so much automation in some of the planes like the Cirrus that if the automation goes wrong, people are like, I don't know what to do, right? I don't know how to fly this plane, and it's kind of bad. So you can't make people look at those mechanical instruments, but they're pretty hard to hack, right? In some cases, you can affect the autopilot operation. However, if the pilot notices, they will disconnect the autopilot. Also, all autopilots have to be able to be overridden physically, right? So if you have an airliner and you have a 90-pound supermodel and, her night job is flying a big Boeing, she has to be able to override the control forces on that aircraft. And that's the rule. Otherwise, you can't get it certified. Okay. So talking a little bit about some of the bigger airplane. Some of the big airplanes, they have really sophisticated systems for the avionics to talk to each other. And the older planes, the big ones, use something called AirInc 429. Right? And that's just a standard for talking between different components. Now, newer aircraft tend to use a modified version of Ethernet that is called AirInc 664 or AFDX. Right? So AirInc is just a set of standards, kind of like you have ISO standards and IEEE standards. Well, this is for avionics people. And, why did they do that? Basically, they wanted to use COTS, common off-the-shelf components. They're like, hey, this is really hurting us. It's hard to get all this proprietary stuff together and to try to test these things. So let's use Ethernet. People understand Ethernet. Now, one thing you have to understand about this AirInc 64 or AFDX is it's not the same Ethernet that you use, right? It's like saying, I have a video cassette tape, and I know some of you are like, what's that? You know, okay. It's this thing we used to have before everyone had DVDs, which is, you know, what we had before everybody had Blu-ray, which is what we had before everyone had 4K Blu-ray. But anyway, you know, if you go back a long ways, some people actually use this thing called Betamax. So it was a videotape, but it wasn't a VHS tape. So it wasn't exactly the same thing. Other things to know about this protocol, it's never wireless. There are reasons why they will run miles and miles of wire in a big airplane. It's because it's reliable. And there is some security in place. It's not directly connected to things like entertainment systems and in-flight Wi-Fi. All right. So this was originally developed in the 777. And as I said, lets you use common off-the-shelf stuff. Not the same as your father's Ethernet. It uses redundant channels, and it assigns time slices to make things deterministic. Now, if you learn anything in aviation, you'll learn that aviation is all about redundancy and safety. You know, people are like, hey, why are you using 1930s technology in the engine in your Cessna? Even your Cirrus, same thing. And the answer is because it works, right? That's why we use it. We prioritize that over efficiency any day. It's like, yeah, this would be more efficient and all this, but this works reliably. So we're going to go with what works and works all the time. And so we have redundant channels. The other thing that we have to do is Ethernet's not deterministic. I can't send out a packet and then know when I'll get a response. So instead, what we do with this protocol is we time slice things. So you get your time slice, you know that your packet gets out, there won't be a collision, and you know that you'll get a response within a certain amount of time. So it's a deterministic system. And the way that it works is that it uses virtual links. So a virtual link is just a virtual pipe that connects two processes, and there's one and only one sender, and there can be one or more receivers in the system. And we use something called a BAG, a bandwidth allocation gap, and that determines the time slice size. And then we have jitter, right? And it's related. You know, what's the maximum latency that you can have? When we look at it physically, again, there's two links. There's an A channel and a B channel. And the way that it works, they both send out packets. Whoever packets arrive first, they win, right? So one thing, if you were trying to hack into the system and you're like, oh, well, I'll just, you know, connect a garden variety Ethernet adapter to this system somehow and send out packets. If you're only connected to one channel, it might work for a little while, but it's going to alert, right? It's going to alert in the cockpit because they're going to be like, hey, there's a wire broken. You need to send this sucker to maintenance, right? And you're going to know that something's going on. This is just a little part of a schematic showing you how some of these things are connected. If you see the FMS box, that's the big box over on the right. That's a flight management system or autopilot, if you will. And here's different things that it's connected to, you know, like the joystick to guide the aircraft and various other things. When you look at these schematics in more detail, you'll see, you know, there's some paths that are a little bit more important than others. Now, one thing I should say is this is a schematic, right? As a schematic, it's not going to show you certain components. And one of those components is a networking switch, right? So if you look at avionics switches, every single connection in there has to be programmed, right? So I have a connection from port 1 that maybe has some sort of a sensor on it, and port 2 that, let's say it's connected to my flight computer, right? That connection is programmed so that port 2 can only receive from a certain number of ports, and port 2 can only transmit to another set of ports, right? So you have a lot of restrictions. So every single connection in that switch has to be explicitly programmed, right? It's not like, oh, I can just start sending, fake packets around this avionics network and things will happen. Well, it's a lot more complicated than that, right? Okay, real quick, entertainment systems. So you got an entertainment system, and what's a common component in these entertainment systems? You want the little screens, like here's the map of your flight, here's where you're at, here's how long it's going to take, here's how fast you're going, all that other stuff, right? So where are you going to get that? Well, there's a couple places you can get that information. One of them is directly from the GPS or the FMS. And if you're getting that information that way, it's connected through something called a NED, a network extension device. Important to realize this stuff is never like connected into that AirLink bus or anything like that, right? Also, never wireless, not your father's TCP IP, right? So, here's just one diagram for a system. I won't tell you which aircraft this is, but just showing some of the interconnections between the in-flight entertainment and some other systems. All right. Real briefly, there was some confusion. A lot of people out there were confused with the 777 because of something that the FAA said. Boeing asked them for a special condition to allow the passenger information network to be connected to other networks, and they granted them this condition as long as they used a NED, right? So, one of the things they said is that there had to be isolation from or airplane electronic system security protections against bad things, right? I'm not going to read the whole slide, but so what is this NED, right? You're like, I've never knew a guy named Ned, all right? Well, now you do, okay. It's basically a gateway. Now, remember, a gateway is often a translator, right? It goes from this protocol to another protocol. In the case of a NED on your airliner, it's going to go between the AirLink protocol, whatever it is, and your garden variety TCP IP that the in-flight entertainment system is going to use. So they're not talking the same language. It's a translator. And like most gateways, every path has to be programmed, right? I can't just say, hey, there's a connection, right? In security, we have this kind of general rule. If a wire connects two things, there's always the potential for hacking, right? Would you guys agree with that? If you're connected to something, there's a potential that you could hack it. And I'm not going to say it's impossible here. I'm just saying that in this case, you're talking different languages. So it's a much higher barrier in order to try to do some sort of attack. And here's the other issue. All right, so the gateway has to be programmed. So the gateway is not normally going to receive any inputs at all from the cabin, right? It just outputs to the cabin. And the switches, those avionic switches I was talking about, they're not programmed to receive inputs either for those ports that connect out to the NED. Right? So there's multiple barriers that you're going to have to overcome if you're somehow going to try to go from there into the cockpit. Here's a picture of one NED. I just stole it off of the manufacturer's site. Manufacturers are great, right? They'll tell you all about their products because they want you to buy them. Earlier, there was a talk, and they were talking about these different venues and how do you get all the information in the venues. You go to their website, and they're like, hey, here's all of our security and all of our wonderful things that we do. They're trying to make your life easy. Buy our stuff. All right. Another thing I wanted to talk about briefly, a few years back, I guess this was about 5 years ago now, there was this Malaysian Flight 370. Who remembers this? Right. So this plane disappears, right? And what did a couple people come out and say immediately? It was cyber hijacked, right? Oh, must have been that. They're like, that's kind of a leap. It's not is it the first aircraft that ever disappeared? No, right? But a lot of people went right to that. And then, of course, there's the big conspiracy theories. You guys always have conspiracy theories, right? What would the world be without them? You know, but, one of the things that a lot of the conspiracy theory types actually talked about, they said, hey, you know, there was these signals that came, you know, after it went off radar. I'll talk about that in a little bit. Okay, but so again, if you're thinking that somebody in the aircraft maybe hacked in through the in-flight wireless and did all these other things and somehow it disappeared, I'm not saying impossible. I'm just saying pretty hard.
Hello, and welcome to How to Hack Into and Take Control of a Commercial Airplane. Step 1. When trying to get access to the plane's navigation system, try to utilize the plane's in-flight entertainment system. This is near to impossible, but with enough typing and hacker buzzwords such as
I'm in.
And
I've rerouted the network interface.
Also
I've got in the router girder. Yeah!
You can make it seem like the in-flight entertainment and navigation systems are connected and thus frighten an air marshal enough to incapacitate you. With enough hacking, one could be able to sign onto the plane's Wi-Fi for free.
All right. Anyway, that was just a fun little video a friend of mine made. We got some more fun videos later, but you know, talking about in-flight wireless. Again, this in-flight wireless entertainment typically not going to be connected to anything really important. I will say this though. There are some GA planes out there, typically business jets, that do offer in-flight Wi-Fi. Now, those may not be so separated, right? So, you know, if you're looking at a little biz jet, then yeah, there's a lot more possibility that you could actually attach to something kind of important. Of course, my question is this: you have to be in that airplane, right? Hacking the airplane that you're in doesn't sound terribly smart. And, you know, it's a little biz jet. It doesn't have a fortified door blocking you from the cockpit or anything. It might not even have a little curtain, you know, depending on what it is. There are easier ways to attack that aircraft. Okay, a little bit about ADS-B. How many of you have ever heard of this ADS-B thing? All right. So it was created initially in Alaska, right? So ADS-B is this idea, it's something where planes talk to each other, right? They send out signals. It's meant to supplement radar in bad coverage areas like Alaska. A lot of you might not realize this. Alaska is huge, right? And they have more planes than cars in Alaska. What's one of the biggest problems in Alaska? Plane crashes? Well, it's related to that. Drinking and flying, right? They got more planes than cars, kind of makes sense. You know, a lot of people get drunk and they fly anyway. But anyway, this is part of this system called free flight that, you know, maybe someday we'll actually get it. The whole idea is planes talk to each other and they kind of work out their differences. They're like, hey, we're kind of colliding. Let's not do that, right? Now, ADS-B can also, if you receive these signals, you can get traffic and weather and things like that, right? Now, that's a lot of people have heard of ADS-B. This is not what airliners use. Airliners actually use something called ADS-A, which is addressable, right? It's related to something called ACARS. ACARS is a messaging system. And it's like this. ADS-B is your cable-ready TV. ADS-A is your cable box, right? So you can get pay-per-view and things like that with ADS-A, if you will, because it can know who you are. Whereas ADS-B, it's just like, this is me, right? And there's a lot of good things. There's this rule out there that says by January 1st, if you're flying in certain airspace, you have to have a transmitter for ADS-B, right? And we'll talk more about that here in a little bit. Related to ADS-B in, we have this system called TIS-B, Traffic Information Service B. It's based on ADS-B. And this is provided by air traffic control. And if you have an equipped aircraft, I can look possibly at my GPS or other screen, and I'll see other airplanes around me. And it's sort of the poor man's collision avoidance. I don't get every airplane. I only get the planes that are under radar coverage that air traffic control knows about, and their ground station relays back to me. And they don't have to relay every aircraft back to me either, right? Other collision avoidance systems that you might see, little airplanes have something sometimes called TCAD. It's called TCAD because it sounds a lot like TCAS, but it's nothing like that. It's, something you buy for cheap, and basically it's not authoritative. It just kind of says, I think there's an airplane over there, right? And then we have TCAS. TCAS is what the big guys use, biz jets and up. Right? Now, on a TCAS system, sometimes they'll say the fish finder. If you look at this, I just realized that my slide is somewhat truncated. I apologize for that, but it looks great on my screen, by the way. But so it looks kind of like a fish finder. That's why they call it that. And when I was in Iowa, we had a professor in our aviation program there. He'd always say things like, they call traffic. He said, I have them on the fish finder. I'm like, you don't have a fish finder. You got one of those, cheap little GA things. But anyway, so what do the TCAS systems do? Here's the most important part about this. TCAS systems don't use ADS-B signals, right? You're not going to get an alert in your big airliner or your biz jet because I spoofed ADS-B signals. How hard is it to spoof ADS-B? Software-defined radio, ever heard of it? I mean, it's super, super easy. Like, I can make fake ADS-B signals all day long. It's probably not very ethical or legal, but, I could do it. Right? The technology is very simple. But these guys don't use it. Instead, what they use is a transponder signal. So transponder, if you don't know what that is, it's basically a little box in your airplane. When radar hits it, it goes, hey, someone's looking at me. I'm over here, right? And I have a little number. So you look at the bottom screen, you see 1200 is on the display. That's the I don't have a code, right? And it also sends things like your altitude, all right? By the way, this is like the only real world current application of octal. This is called a 4096 transponder because it has 4 octal digits. Some of the other professors at my university are really big on making people learn octal. And I'm like, this is the only place I've ever seen people using octal is transponders, right? Now, the airliners have at least 2 of these guys. And here's what the TCAS system does. It uses a directional antenna so that as it flies through the air, it just sends out signals. And it says, hey, if you're out there with a transponder, please respond. And then it uses the directional antenna and the delay, and it says, oh, I see you're over there, and here's your distance, right? So it's pretty hard to spoof that. You know, I can't be sending signals over here and thinking that that is somehow going to be interpreted as signals from the other side of my aircraft, right? It's a pretty hard thing to spoof.
To force the plane to reroute to another location, or at least harass the flight crew, simply have your pilot friends fly multiple planes in front, behind, and around the plane you would like. Have said planes send thief transponder signals to the hijacked plane and force it to react to resolution advisories. The crew may possibly reroute to another location.
This is real high tech. No, it wasn't. A couple of planes.
It seems like a lot of work. Why don't we just borrow that one?
In actuality, here's what would happen.
ADS-B attack.
Initiated.
We're glad that nobody can hack into the airplane. That'd be embarrassing.
Okay, so again, you know, when it comes to like the little planes, maybe things are a little bit different. All right. So if you have a small airplane, like even my 1960 Cessna in my flying club, okay, the thing has got no GPS or anything like that. So sometimes I bring my own, right? I'll bring a tablet and I might hook it up to a unit, kind of like this guy, little guy in the corner. This little guy in the corner is called a Stratux, not to be confused with a Stratus. What's the difference between a Stratux and a Stratus? Several $100. That's the difference, right? And Stratux, it sounds very, what? Linuxy, open sourcey, cheap, right? You can buy these units, or you can build your own for less than $200, right? So what has it got inside? It's got a Raspberry Pi, and it's got a dual channel receiver. So there's actually 2 channels that ADS-B is transmitted on. Okay? And it has something called an AHRS unit, which tells you which way is up. So it's essentially electronic gyros. Less than $200. And it integrates with my tablet. It's got synthetic vision. It's really cool. I can feel like I spent $500,000 on a Cirrus, and I spent like $500 total, right? I got the exact same effect. So these guys, yeah, if you start sending out false signals to this kind of a system, I'm going to pick it up. And I'm not going to know that that's a fake system, right? Now, it's not connected into my avionics. It's not like it's going to reroute me because it's not connected to my autopilot or anything like that. But you can certainly mess with me, right? And that's kind of true in general. You can really mess with the GA pilots. It's a little bit harder to mess with the big guys, right? But I certainly can do this. In fact, the other day, I was flying into the Lancaster airport, and air traffic control was like, yeah, I see some traffic in front of you. Do you have them in sight? And I looked and I'm like, yep. Yeah, I think I see him. He's my 2 o'clock. And he said, could you estimate his altitude? And I looked at my tablet and I said, I would say his altitude is about 2,500 feet and his tail number is N33 because it actually had it on my display because I was receiving a signal from him. And you might say, well, then how come the tower didn't know who he was? He was not within range of a ground station where they could receive his ADS-B signal. And they didn't get his transponder for some reason, right? So things like that happen, right? All right, so here's some new attacks. I mentioned that we have this new mandate. And this mandate says come January 1st, if you're flying in certain kinds of airspace, you need to have ADS-B out. So my flying club, we have this older Cessna we bought earlier this year. We're using it as a trainer. It's great. I love it. My kids love it because the windows are bigger than the new Cessna and you sit up a lot higher. It's just pure flying. It's not adulterated by electronics and screens to look at. You actually look outside, even the gyros in it. The gyros, normally they're vacuum driven and you have a pump on the engine that creates suction, which spins these things. Nope, no, we don't need anything like that. We have these Venturi tubes on the side. So it works great, but only after you've been flying for like 10 minutes. So, if the weather is kind of low, it's like you better go taxi up and down the runway a little bit and get those things spinning before you get up in the clouds and be like, I'm not sure which way's up. But anyway, so our club decided, all right, initially we were going to say, forget you, and we weren't going to comply with this ADS-B out thing. We just wouldn't fly down to Philadelphia and things like that. And they changed their mind. They're like, okay, we're going to comply with this. So there's this company, Avionics, and they make a lot of products. And they have made their company based on this product pictured and something else that's very similar that works on a wing light. Okay. And here's what their company does. They make these little things where you take off one of your navigation or position lights off of normally your wingtip, and you put their special light in its place, right? That special light has a GPS receiver, a high precision GPS, so that it can send out your position over ADS-B, an ADS-B transmitter, a altitude sensor, and some other smarts. It actually uses the power wires that go into this unit as an antenna to receive the transponder transmissions to go, oh, your transponder just fired, and here's the code that it just sent. So let me take that information and put it together, and I'm going to transmit the appropriate ADS-B signal that goes with that transponder reply, right? Which is kind of cool, right? Now, why do people buy these things? Because they're only $2,000, right? You're like, well, that's seems like a lot. Well, when the FAA first came out with this rule, I think they gave us like 10 years of notice, and everyone's like, FAA never does anything on time. They'll push it back. They'll push it back. And initially, it was at least $5,000 to $6,000 to comply with this rule. And again, if you do ADS-B out, you get absolutely nothing as a pilot. It's no benefit to you at all, right? You have to do the receiving in order to get a benefit, to get the weather and traffic and stuff like that. So a lot of people were like, I don't know. And then Avionics comes out with this thing. You're like, just replace your wingtip and it's going to be super easy, right? I actually installed this guy. This guy goes in the tail light. It's slightly easier, I think, than the wingtip lights. And I installed it, a couple hours, configured it, and it was super easy, right? So these things are really popular. Well, how do they work? Well, you have a smartphone app. Again, they made it easy for people. You just pull out the old light, pop in this new thing, and get out your smartphone. You turn the thing on, and for the first 5 minutes or until you leave the ground, it says, hey, let me set up a Wi-Fi hotspot. And if you connect to it using your little smartphone app, you can configure this thing. Guess what the security is? Do you know the network password? That's it. If you can guess the network password, you're good. You can reconfigure this. I mean, I could take my little 1960 Cessna and turn it into a Boeing 787 for United Airlines. I don't know. I mean, it's super easy to just change it. All right. Or, maybe there's something called anonymous mode. I can set this unit to be in anonymous mode, so I'm not telling the whole world my tail number as I fly around the sky. Right? You could reset that. I mean, there's all these things you could do. So, what do you guys think? Security fail? To configure it? That's part of the... Yeah, you just... in fact, you can go to their website and they'll show you a video tutorial. I think my total time to install this unit, configure it, and do all the paperwork was about 3 hours. And to be fair, the biggest part of that, well, first of all, it started raining, so I was working on the ramp in the rain, which kind of sucked. But this particular airplane, someone upgraded it so that these little lights flash. So I had to find this stupid flasher unit and then disable it, which, I ended up like removing seats, crawling up under the dash. And, that was like the biggest pain in the butt of this thing. So, if I hadn't had to do that, you're looking at probably hour and a half or so. So it's like super easy to do. You save on shop time and, people like that. But, I'd say it's kind of problematic, right? Okay. Question? Well, otherwise, how would you configure it? Well, it's gonna transmit that you have an aircraft, and actually the anonymous mode still sends your identification. It just doesn't send it in the same way so that the average person can see it. Air traffic control can see it, but not everybody else. But I don't have time to get into that and how that works. But okay, real quick, a couple other things. Some people have talked about things like attacking engine systems. A lot of engine systems have monitors, and some of the information can be sent out on something called ACARS. I'll talk a little bit more about that right now. So ACARS is a system that is used to send messages to and from the ground. This is used all the time. It's used for things like weather, flight delays, flight plan updates, maintenance stuff. The lav is broken. Sometimes it's used for passenger manifests. A lot of different reasons that it might be used. Many of the components on a big airliner will actually send out these messages. Right? The engines send information, and you're like, why would they do that? For maintenance. Rolls-Royce tracks the engines. The airlines track the engines. What are the parameters? What's going on? I want to know that, right? I want to know, hey, is there something that's not right? And I need to address that next time the plane goes in. Is there something that the manufacturer of that engine wants to know, right? So they send these messages all the time, right? So could you attack ACARS? Yep. It's not encrypted or anything. You could send out bogus messages. Probably not a practical way to take over.
From the ground, one may be able to take control of the flight's ACARS message, where a crew receives flight plan modifications and ATC clearances. Make sure to send the orders to a pilot who doesn't verify the change in flight plan.
I don't know about that. We better verify that with company. Hey company, this is 2734. Can you just confirm, we just got an ACARS message saying we need to reroute to Cuba?
No, that is incorrect. Play stay on course.
continue on course to Fargo then.
Okay, so again, by the way, thanks to a friend of mine, Polly Kadolf, over in Dubuque. She made those funny videos. But issues that you're going to run into with that, there's protocols, right? There's protocols and procedures in place. So, for example, if you say, hey, you're going to reroute, the immediate action from the pilots will be to contact the airline and ask. They're going to verify that, and they're going to say, no, we didn't tell you to do that. Right? Now, again, is there possibility, like, can you send bogus ACARS messages? Oh, yeah. Yeah, you definitely can. You could, like, hack into a ground ACARS unit and send out messages all day long. There's no encryption. There's no validation or anything like that. So there certainly is potential there. And what is going to prevent attacks? It's going to be people who actually follow procedures and verify things. You might have better luck with something a little bit less drastic than, hey, you're going to Cuba, not Fargo. But anyway, so just a couple closing thoughts. Nearly every protocol used in aviation is not secure. It's not encrypted. Even the radio. I remember one day I was flying around Atlanta and some kids were on the radio going, Mayday, Mayday, Mayday. They're like making Mayday calls. And then the controllers are like just having to verify that, did anyone declare an emergency? And everyone's like, no, it's some idiot kids, right? Now, increasing automation without securing those protocols could be problematic. I mean, it doesn't sound like a great idea. And I would say that airliners are pretty safe. I wouldn't be worrying about people hacking into these systems. There's so many other easier ways that people could be attacking those systems in general. But if you really just don't like general aviation pilots, you can just annoy the crap out of them, honestly, especially if they got the cheaper stuff. So that's pretty much it. I maybe have time for one question, it looks like. But don't feel any pressure to ask. Yeah.
So I saw one of the Bruce Willis films in which they actually made the airline of the airplane pilots think that the ground was at a different level than the ground was. So you're saying that part
It makes a good movie, doesn't it? Yeah. And again, if you're talking about an airliner, so an airliner is going to have some sophisticated stuff where, if you're close to the ground, they usually have what we call radar altimeters, which literally reflect radar signals off the ground. So when you're low, you would know that. And that's going to be tied into that TCAS system. And you're going to get alerts, and they're going to tell you, pull up, you're low. So, hopefully you would notice it. There have been crashes not related to that or any kind of hacking, but there was actually an airplane that crashed many years ago because a light bulb was burned out, and the crew were so distracted by that, they even sent somebody down into the bowels of this airplane to verify that things were working correctly, and they disengaged the autopilot, and they didn't notice, and this plane crashed. But yeah. Okay, let's see. Quick question. Okay, that's a good question. And the answer is no, for a couple reasons. Number one, if I send in a new flight plan using ACARS, it has to be reviewed and manually accepted by the pilot. So the pilot has to approve the change. It's not like, oh, here's a new flight plan, and then woo, off it goes. And again, if you somehow could not disengage an autopilot, you can always override it. Not that you're going to enjoy that, not that you're going to enjoy, muscling your plane around the sky for a little bit, but you're always going to have that. So, all right. Well, I'm out of time, so thanks for listening, and enjoy your next talk.